Hello guys and welcome back. So now we're going to find the curves that intersect with the geometry, and if we look at the geometry, there's ones that don't touch the geometry at all, but anything that is behind the geometry is most likely going to go inside this. So what we need to do is we need to find which one goes inside this this guy. And the easiest way to do this is using volumes, using VDBs. So I'm going to create a VDB from Polygon, convert this into an SDF, and fill the interior. I'm going to leave this resolution. And this is a volume now. I can use the point VOP and a volume sample to see which points are inside this volume or not. So let's create a point VOP. And this is the result. Let's create a point VOP. This is my input. This is my SDF. Let's dive inside. Let's do a volume sample. The sample is from the second file, second input. The sample position is this, and let's connect this to the color. And if we do that, you see there is black and there is white. So whenever the curve is inside the geometry, it's black. So let's take a look at these values. See, it's negative here and positive here. And let's see what the negatives mean. So I'm going to use a compare. If the value is less than zero, I'm going to give it a different color. If it's brighter, if it's higher than 0, I'm going to give it a value of 1 or give it a different color. So I'm going to use a compare. And I'm going to compare this result, which is a float. So less than 0. I'm going to use a two-way switch that uses this condition. If this condition is true, I want to use a constant color. And it's red. If it's false, I'm going to use blue. Connect this. And now everything that is inside the geometry is getting red. Everything else is getting blue. So what we need to do is we need to find the curves that have red on them. Okay? So the easiest way to do this, I'm going to set this to white and this to 0. So if the curve has is inside, it's white now. If not, it's black. And the easiest way to do this is using something called attribute promote. We can take any attribute from its class and promote it. So we can move these colors into a primitive attribute. But when we do that, we can use a math operation or promotion method. So I'm going to change the color attribute from point to primitive, and the method, instead of average, it takes all the points and averages them. I'm going to set it to a minimum. A maximum. And what that means is it takes the highest color and use that across the board. If we set it to a minimum, it will use the minimum color along that curve or across all those points and promote that to the primitive level. So I'm going to use a maximum, and that way the white color is going to be touching the entire curve. Okay? And now I can use a blast node and say delete everything that has white. So cd.x is less than 0.5. I want to delete the primitives and delete non-selected. And let's use the fancy coloration. And now what we're left with is everything that did not intersect with the geometry. Okay, so if we increase this curve, for example, made it bigger, maybe for the stuff behind, we should have a higher chance of having curves following this nicely. But I think this works right now. So let's increase the number of points. The number of points to get more curves. We have 600 primitives. Let's increase this to 10,000. It's doing the for each loop. And these are our curves. Let's zoom in. See, they're all pointing along the normal direction. And none of them, trust me, none of them is intersecting with the geometry. And now we can convert them into wires. Let's just see 3 million points. I'm gonna resample them using the facet node. Okay. And let's lower this to 0.25. Cool. So now we have a lot of curves. And here you see the distribution is pretty cool because the points are not overlapping at all. I mean, there is overlapping here, obviously, because of all the noise that we've added, but I think it's pretty cool. So we're gonna add a few more things to this. We're gonna add the wire sim to have them drop on top of each other and collide. And we're also going to create the points that travel along these curves. Thank you for watching, and see you in the next video. Bye bye.